Welcome to science, to sleep by. Tonight, we drift into the dark, to the quiet corridors between suns, where something ancient is moving. Its name is 3I Atlas. At first glance, it was just another comet, a visitor, a flicker of frozen light passing through our solar system. But as telescopes traced its path, astronomers began to whisper the same phrase again and again: it's stranger than we thought. So, as you settle into the calm of night, let's unravel this mystery together, one quiet question at a time. Because in the stillness of space, even silence can tell a story. This is Science to Sleep By. When astronomers first caught sight of the object now known as 3I Atlas, there was a quiet sense of déjà vu in the scientific community. A feeling that something strangely familiar had entered our solar system again. Another visitor from the dark, like the mysterious Oumuamua that passed us by years before. Yet this one, even in its earliest detection, seemed to whisper something new, something more complex. Its arrival was calm, subtle, but beneath that calm, it carried secrets that would soon rattle everything we thought we understood about interstellar travelers. It came from nowhere we could trace, moving at speeds too high for any object bound to our sun. The first images showed only a faint streak, but astronomers noticed immediately that its orbit could never close upon itself. It wasn't from here. It was coming through, just passing by, carrying a story no one had heard before. At first, the world hardly noticed, a small dot among countless others in the black. But the few who did notice it, those late-night sky watchers, those quiet astronomers in frozen observatories, felt the same pulse of curiosity that had greeted our first interstellar visitor years ago. What was this thing, gliding silently across the solar plane, untouched by our sun's gravitational embrace? They called it 3I Atlas, the third known interstellar object ever detected. The name itself carries a hint of poetry. Atlas, the telescope that found it, named after the Titan who held up the heavens. And maybe that's fitting, because 3I Atlas seemed to be holding up a new piece of the cosmic puzzle we hadn't expected to see again so soon. As data trickled in, scientists compared it to everything they knew about comets and asteroids. Its brightness curve, its orbit, its apparent composition, but nothing fit neatly. Some thought it was a comet after all. It showed signs of outgassing, faint trails of dust perhaps, or frozen volatiles boiling away under solar heat. Others disagreed, pointing out that its activity seemed inconsistent, intermittent, even artificial in rhythm, like a pulse with no heartbeat. The mystery deepened with every observation, and every telescope aimed toward it seemed to find more contradictions. Unlike most comets, 3I Atlas appeared to brighten not as it neared the sun, but erratically, in unpredictable surges. That was the first clue that something was off. Normally, comets obey the laws of temperature and light, icy surfaces vaporizing under solar radiation, creating long tails of gas and dust. But this one behaved as if it were responding to something else, as if its brightness were governed by internal changes we couldn't see. Some nights, its reflection looked like a shimmer of crystalline frost. Other times, it appeared dull, metallic, and lifeless. The data simply refused to tell a single story. Astronomers began digging deeper into its motion. They noticed that 3I Atlas wasn't moving exactly the way gravity alone would dictate. It had what's called a non-gravitational acceleration, a tiny but measurable push, like a faint breath of force coming from within it. That same anomaly had been seen before, with Oumuamua, and it reopened old questions that scientists had tried to put to rest. Was this object shedding gas in microscopic jets too faint to detect? Or was it something else? A shape so strange that sunlight itself could be nudging it off course, like a sail catching a breeze in the cosmic wind. Every discovery seemed to make 3I Atlas more alien, not less. Its speed, its brightness, its unpredictable fragmentation, they didn't fit the normal behavior of anything we'd cataloged from our solar system. When astronomers mapped its origin, the trajectory traced back not to a nearby star, but to the cold interstellar void between systems, where temperatures hover near absolute zero. That meant 3I Atlas had likely been traveling for millions, maybe billions, of years before we saw it. A wanderer older than our civilization, older than humanity itself. And yet, for something so ancient, it felt strangely alive. It seemed to react, to shift, to resist. Simple explanation. Its fragments didn't break apart like ice or rock, but scattered in formations that some models couldn't replicate without invoking exotic materials, compounds of carbon, metal, and silicate that shouldn't have held together the way they did. Even when scientists simulated its disintegration in computer models, the patterns came out wrong. Nature didn't seem to play by the same rules with this object. It was as though 3I Atlas carried the chemistry of another galaxy, a fingerprint of a place no one had ever seen. When the news reached the public, curiosity surged again, much as it had during the Oumuamua debates. Was it a comet, or something else? A shard of a broken planet? A remnant of a long-dead star system? Or could it be, as a few speculative voices dared to suggest, a fragment of something built rather than born? The scientific community didn't entertain that lightly. They knew how quickly imagination could outpace evidence. But still, 3I Atlas refused to fit into any familiar category. As it drifted closer to the sun, telescopes from around the world joined the observation effort. The Hubble Space Telescope, the Very Large Telescope in Chile, and several ground-based survey stations across Hawaii and the Canary Islands. Each one added more data, but none provided certainty. The more we watched, the less we understood. The mystery was returning, deepening, and with it came that strange mix of awe and humility that only space can inspire. There's something haunting about watching a visitor like this pass through our solar system. It's a reminder that the universe is not static or silent, but full of wanderers, fragments of other worlds crossing paths with ours by pure cosmic chance. They come without warning, reveal themselves briefly, and vanish forever into the night. And maybe that's what draws us toward them, the fleeting nature of their existence, the way they challenge what we think we know about creation and destruction. For scientists, 3I Atlas became more than a puzzle. It became a mirror, reflecting our own desire to find meaning in the unknown. Each observation, each data point, was like a whisper from beyond our sun, urging us to look closer, to question harder, to remember that the universe still holds secrets far greater than our understanding. And so, once again, humanity found itself standing at the edge of discovery, peering into the void, wondering not just what 3I Atlas was, but what it meant that it came to visit us at a Limogene, a place beyond the reach of sunlight, a realm colder than anything our instruments can truly measure, where space itself feels almost solid in its stillness. Between the stars lies an ocean of emptiness that seems eternal, but even there, objects wander, tiny fragments, relics, travelers, drifting for eons through the deep black. 3I Atlas came from that kind of darkness, a place not bound to any sun, not tethered to any planetary system, but cast out into the interstellar gulf long before our species ever looked up at the sky. It is not just a rock, not just ice. It is a message written in the language of dust, distance, and time. And now, it has crossed our path. The discovery that 3I Atlas was interstellar didn't come instantly. Astronomers first tracked its trajectory and noticed how its orbit didn't make sense for something born under the sun's influence. It wasn't looping. It wasn't turning back. It was simply cutting through space, moving too fast for the sun's gravity to ever pull it into a closed path. That alone was enough to set it apart from the billions of comets and asteroids we've cataloged. Everything born here circles home. Everything from elsewhere simply passes through. The mathematics told a simple story. This visitor came from the in-between, the quiet abyss separating one star from the next. But what does that mean, exactly? The space between stars isn't just empty. It's filled with gas so thin it would take a billion atoms just to fill a cubic inch, sprinkled with ancient radiation, and occasionally astonishingly with solid objects like 3I Atlas. These wanderers are the cosmic castaways, the remnants of systems long gone. Some were likely born around alien suns, torn away by gravitational chaos. Perhaps when planets collided, or stars passed too close to each other, or entire systems were disrupted by supernova. The fragments ejected in those violent moments drift endlessly afterward, untethered, crossing the light years until they stumble into another star's domain. 3i Atlas is one such traveler. It carries within it the chemistry of another world, one that formed under a different light. When scientists studied its faint reflections, they noticed subtle differences in its spectrum, small shifts that hinted at materials slightly unlike what we find in our own comets. Ratios of carbon to oxygen, the crystalline structures of its dust, even the faint signature of organic molecules seemed skewed in ways that told of foreign birthplaces. It was as if the object had been sculpted by a different recipe of starlight and time. The darkness between stars had preserved it, encasing it in the cold silence of space for perhaps billions of years, until gravity's invisible hand nudged it toward us. To drift through the interstellar medium for that long means surviving in a place where there is almost nothing to protect you. The radiation from passing stars, the slow abrasion of cosmic dust, the relentless freeze, near absolute zero, all of these shape such objects in ways we can barely model. 3i Atlas has been polished by eternity. Its surface might be layered with complex hydrocarbons, darkened by millennia of radiation. Its once bright ice turned tar black. Astronomers think this is why it appears so dim, and why it reflects sunlight in an uneven way. The outer shell of 3i Atlas is likely coated with organic compounds created by cosmic rays bombarding its frozen core. Beneath that layer, deep within, may lie ancient ices, water, ammonia, carbon dioxide, still pristine, still untouched since the birth of its home system. That makes 3i Atlas more than just an object of curiosity. It is a sample of another solar system, a messenger from across light years, carrying in its structure the conditions of a distant world's formation. Every molecule inside it is a record, a clue to how other stars build planets, how chemistry unfolds in places we'll never reach. By studying it, scientists can compare how our solar system's ingredients differ from those of others, how the cosmic recipe changes from star to star. In that sense, 3i Atlas is both alien and familiar, a fragment of someone else's origin story drifting through ours. What fascinates researchers even more is the timeline such an object implies. To have traveled interstellar space and found its way here, 3i Atlas may have been launched billions of years ago, possibly before Earth even existed. It could have witnessed the birth and death of countless stars, passed through the glowing filaments of nebulae, skirted the edges of supernova remnants, and glided through invisible rivers of dust that stretch across the galaxy. Each journey would have changed it slightly, altered its spin, eroded its edges, coated its surface with the faintest traces of cosmic history. By the time it reached our neighborhood, it had already lived a story older than humanity itself. When telescopes turned toward it, the light reflecting from its surface had traveled millions of miles through our solar system. But the atoms in that light carried the memory of much older distances. Some astronomers described it poetically as if 3i Atlas were a grain of the Milky Way's memory, passing briefly through our reach. The spectra it gave us were like words spoken in a dialect of chemistry we barely understand. Even now, the analysis continues, each measurement opening new questions about its density, composition, and color. And every time a new reading contradicts the last, it reinforces one profound truth. This object did not come from here. In a way, 3i Atlas invites us to reconsider how we think about space. We tend to imagine the regions between stars as barren, silent, endless. But 3i Atlas proves that even there, in the vast nothing, stories are moving. Invisible highways connect one star system to another through these drifting relics. They are like messages in bottles cast into a galactic sea. Some will travel forever, some will collide, and a few, by chance, will find another world watching. Ours just happened to be in the right place this time, with the right eyes looking up. And there's something almost emotional about that thought that across unthinkable distances and immeasurable time, a piece of another world found its way to us. It didn't come with purpose or intention, but it came nonetheless, and for a brief moment, we could look at it and know that the galaxy is not an empty stage, but a living, drifting network of memories. 3i Atlas is one such memory, preserved by darkness, delivered by chance, carrying within its silence a hint of the infinite connections between the stars. When 3I Atlas first entered the solar system, astronomers were ready. After the mysteries of Oumuamua and Borisov, sky surveys had grown sharper, more alert, waiting for another visitor from interstellar space. And then it appeared, faint, elusive, gliding across the void like a whisper of light. At first, it behaved almost exactly as expected. Its brightness rose and fell as it should have. Its orbit matched the patterns of a comet passing through for the first time. But as the days turned into weeks and the data piled up, small inconsistencies began to appear. These weren't obvious flaws, just faint ripples in the numbers, patterns that only long nights and patient eyes could notice. Yet they were enough to tell astronomers that 3I Atlas was not behaving like anything they had seen before. The first anomaly came in its brightness curve. Comets typically brighten smoothly as they approach the sun, their icy surfaces vaporizing and forming vast hails of gas and dust. But 3I Atlas did something stranger. It brightened in uneven bursts, flickering unpredictably. At times, it seemed to glow more strongly without explanation, then fade again. Even though it was moving closer to the sun, it was as if something inside it was responding to conditions we couldn't see, or perhaps breaking apart in ways no one could predict. When this irregular light curve was analyzed, astronomers realized it couldn't be explained by normal sublimation, the process of ice turning into gas. Something else was controlling its brightness, something far less ordinary. Then came the second clue, the pattern of its fragmentation. All comets eventually begin to shed material as they heat up, leaving trails that trace their path. But 3I Atlas fractured too early, long before solar heat should have caused significant stress, and the way it broke apart didn't fit the typical sequence. The fragments didn't simply drift off in random directions. Instead, they spread along a narrow plane, almost symmetrical, like pieces breaking off from a structured body rather than a chaotic one. The shape of the debris suggested rigidity, order, and perhaps even a surface that was not entirely natural. When computer models were used to simulate the breakup, they showed that a comet made purely of ice and dust shouldn't have behaved this way. The data hinted at a density or internal strength far greater than typical frozen bodies possess. Spectral readings brought even more confusion. As sunlight reflected off 3I Atlas, instruments captured its color and composition across different wavelengths. The results didn't quite match expectations for a comet. There was a lack of clear water signatures, the chemical hallmark of icy bodies. Instead, faint indications of metallic compounds appeared: iron, magnesium, possibly nickel. Some researchers proposed that it could be a fragment of a planetesimal, a rocky core from a shattered exoplanet. Others argued for carbon-rich material, perhaps the residue of complex organic molecules altered by eons of cosmic radiation. The truth was that every new reading seemed to deepen the mystery. 3I Atlas refused to fit cleanly into any known category. As astronomers tracked its motion, another subtle irregularity emerged. The object's path through the solar system showed a tiny but measurable deviation from what gravity alone could explain. This was the same unsettling effect seen years earlier with Oumuamua, a non-gravitational acceleration, as if some faint internal force were pushing it ever so slightly. Normally, such motion could be attributed to jets of gas streaming from a comet's surface, creating a small but steady thrust. Yet, in the case of 3I Atlas, no such jets were visible. No active tail, no plumes, nothing that could account for the force. It moved as if an invisible hand were guiding it, and no one could say why. That realization set off a wave of cautious excitement in the scientific community. Some theorized that perhaps 3I Atlas had a peculiar shape, maybe a flat surface or a sheet-like geometry that allowed sunlight to create a subtle radiation pressure, gently pushing it off course. The idea recalled the debate surrounding Oumuamua, which some had described as a light sail, a thin reflective object capable of being propelled by starlight. Others dismissed that as speculation, suggesting instead that exotic materials like carbonized dust or highly porous ice could produce the same effect. Still, the numbers refused to stay quiet. The object was accelerating in ways that gravity couldn't fully explain. and that made 3I Atlas officially strange. Meanwhile, its rotation pattern added another layer of intrigue. Observations revealed that 3I Atlas was spinning irregularly, tumbling end over end in a chaotic rhythm. Unlike typical comets, which maintain a stable spin axis as they travel, this one wobbled unpredictably. Its rotational period seemed to change over time, suggesting that internal stresses or asymmetric outgassing were altering its balance. But again, without clear evidence of gas emission, the cause remained unknown. The tumbling motion also affected how it reflected sunlight, making it even harder to analyze consistently. Every rotation changed its apparent color, brightness, and polarization, forcing astronomers to adjust their models daily. It was as if the object itself was playing with our instruments, showing a different face each time we looked. Some scientists began to suspect that 3I Atlas was not homogeneous. Perhaps its surface was composed of different materials, metallic regions, interspersed with icy or rocky patches. That would explain why its reflectivity changed, and why its fragmentation seemed to occur in distinct patterns. Others propose that the object might have once been part of a larger body, a fragment of an exoplanet's crust torn away by a collision, carrying with it layers of diverse minerals. The deeper researchers looked, the clearer it became that 3I Atlas was not a simple comet, but a complex, multi-layered relic from a system far different from ours. Then came the matter of its color. Comets in our solar system tend to appear grayish or slightly reddish, depending on their dust and organic content. But 3I Atlas appeared unusually dark, almost black, in certain wavelengths, absorbing much of the sunlight that struck it. This extreme darkness could only be explained by an outer coating of tholins, complex organic molecules formed through long exposure to cosmic radiation. Such material had been seen before on icy moons and dwarf planets in the outer solar system, but rarely to this extent. The surface of 3I Atlas seemed coated in a layer so aged, so altered by interstellar travel, that it barely reflected light at all. This suggested that the object had been drifting through space for millions, perhaps billions, of years, exposed to the silent erosion of starlight and time. Each observation painted a picture of contradictions, an interstellar traveler behaving like a comet, yet lacking the signs of one, a body with strange materials and a strange motion, fragmented yet structured, natural yet seemingly engineered by the universe itself into a form we hadn't anticipated. The deeper astronomers looked, the more the familiar rules of planetary science seemed to blur. The story of 3I Atlas wasn't following the script of a dying comet. It was writing a new one filled with inconsistencies that hinted at something far beyond the ordinary. A puzzle built from the physics of other stars when telescopes first began to sharpen their gaze on 3I Atlas. Astronomers expected to see the familiar silhouette of a comet, a bright nucleus surrounded by a hazy coma, a faint tail stretching behind it, and the soft glow of sublimating ice. But as the data streamed in, something about its structure seemed distinctly different. It wasn't surrounded by the misty halo that characterizes comets nearing the sun. There was no steady plume, no clear evidence of a dust-laden atmosphere. Instead, it appeared oddly compact, sharply defined against the dark canvas of space. To many observers, it looked less like a glowing ball of ice and more like a piece of something rigid, angular, and foreign. Early shape modeling began when variations in its light curve were analyzed over consecutive nights. Normally, as a comet rotates, its brightness changes in a predictable rhythm, allowing scientists to infer its approximate shape. But 3I Atlas showed an erratic pattern, suggesting a body that was not spherical or even elongated in a smooth way. The fluctuations hinted at irregular geometry, perhaps a flat, disc-like object or a jagged, tumbling fragment. Some astronomers noted that its brightness changes were too sharp to be caused by a round surface. Instead, they pointed towards sudden flashes of reflected sunlight, as if large, flat surfaces were catching and releasing light like fragments of glass in motion. This was where comparisons to Oumuamua resurfaced. That first interstellar visitor, too, had defied classification, appearing cigar-shaped to some models and pancake-like to others. The resemblance was uncanny. Both objects shared high speed, interstellar trajectories, non-gravitational acceleration, and now, possibly, a strange geometry. Could 3I Atlas be another object of the same mysterious type, an interstellar shard with a shape that defied natural explanation? The thought wasn't easily dismissed, especially as telescopic data kept supporting it, using high-resolution imaging and light polarization analysis. Researchers tried to estimate the object's surface composition. They expected to find diffuse scattering, as in comets covered with fine dust particles. Instead, the light reflected in a more coherent, directional way, implying surfaces that were smoother, perhaps harder, than ice or dust could maintain after millions of years in space. That kind of reflection could indicate a crust or coating of metallic compounds or silicates fused under extreme conditions. Some even speculated that it might have a layered outer shell, dense enough to survive the stresses of interstellar travel. Even the way 3I Atlas rotated added weight to the idea that it was something physically unusual. It didn't spin smoothly. Instead, it seemed to tumble in a chaotic manner, with its axis shifting unpredictably like an uneven object tossed through the void. This tumbling, combined with the flickering changes in brightness, suggested a body with asymmetrical surfaces, possibly one with fractures, ridges, or panels. For scientists accustomed to the more stable rotations of comets and asteroids, it was a bewildering sight. The data told a story of imbalance, an object shaped by forces or collisions that had left it scarred, irregular, and spinning uncontrollably through space. When models were run to simulate possible shapes based on the light fluctuations, the results leaned toward something surprising. 3I Atlas may have been thin, not in the sense of a flat plate, but elongated and flattened, perhaps resembling a sheet of fractured rock or metallic ice. Such geometry could explain its strange acceleration. It might have caught the faint pressure of sunlight like a cosmic sail, just enough to alter its course subtly over time. Though this theory bordered on the speculative, it was consistent with what the data revealed. Its density appeared lower than typical rocky asteroids, suggesting that it wasn't a solid boulder, but perhaps a lightweight structure, porous or hollowed. Its mass spread thin across a wide surface. Another curious detail came from infrared measurements. Most comets absorb sunlight and ray emitted as heat in predictable patterns. 3I Atlas, however, didn't emit as much thermal radiation as expected. That meant one of two things. Either it was reflecting most of the sunlight away instead of absorbing it, or it had an unusually smooth and reflective exterior. Some even proposed that its albedo, the measure of reflectivity, might vary dramatically across its surface, from very dark regions to mirror-bright patches. This patchiness could create the optical illusion of flickering brightness, reinforcing the idea of a surface composed of mixed materials, some metallic, some organic, others unknown. If it truly was disc-like or shard-like, that shape would have immense implications for how it formed. Natural processes can create flat objects, but rarely in the vacuum of interstellar space. A flat geometry might result from catastrophic impact when planetary crusts or frozen oceans shatter and send fragments into orbit, only for them to be ejected later into deep space. Over millions of years, erosion from micrometeorite impacts and radiation could polish and shape those fragments, turning them into smooth, irregular plates of material. If 3I Atlas had once been part of a larger world, perhaps a moon or planet torn apart by tidal forces, it might now be a fossilized remnant of that ancient violence, drifting between stars as a broken memory of its origin. Some researchers went further, imagining that such shards could be common in the galaxy, fragments of alien worlds ejected during their chaotic youth, stripped from their parent systems and sent spiraling into the interstellar void. If so, 3I Atlas might not be unique, but merely the first of many to cross our line of sight. Each one could carry the physical and chemical record of its birthplace, written in its strange shape and resilient structure. The universe, then, might be full of these silent travelers, natural but unfamiliar, shaped by processes we have yet to witness directly. Yet there were still whispers in the background, as there always are when the data strays too far from the ordinary. Some scientists couldn't help but notice that 3I Atlas's shape and behavior echoed designs that seemed almost intentional objects optimized, in a sense, to move efficiently through the vacuum. Theories of artificial origin resurfaced, not as conclusions, but as curiosities, what-ifs. Could it be debris from a civilization's long-lost experiment, a fragment of technology ancient to recognize? Could light pressure alone explain its movement? Or was there a deeper mechanism hidden beneath the surface? Most dismissed these questions as premature, but even dismissal couldn't erase the intrigue. What made 3I Atlas so compelling wasn't just its interstellar status, it was the way it refused to be ordinary. Its shape challenged our definitions, its motion teased our models, and its silence defied interpretation. Every new observation blurred the line between comet and construct, between natural fragment and cosmic anomaly. The more we studied its geometry, the clearer it became that we were staring at something that had been sculpted by forces, whether natural or otherwise, that we were only beginning to comprehend. The story of 3I Atlas reached a point where science alone could not keep curiosity from turning into speculation. Astronomers were careful, methodical, and grounded in evidence, but even they couldn't ignore the unease that came with every new discovery. The data had become too strange to fit comfortably within the known boundaries of natural explanation. Every orbit recalculation, every spectral reading, every image from high-powered telescopes added more confusion than clarity. It was behaving like a comet in some ways, but not in others. Its rotation didn't match, its light reflection was inconsistent, and its material composition seemed to change depending on where and when it was measured. Slowly, the scientific conversation began to shift from what it was to how far we could go in understanding something that might not obey familiar rules. The more scientists tried to confine 3I Atlas within established models, the more those models began to bend under the weight of contradiction. Theories were proposed, tested, and discarded in rapid succession. Some teams insisted it was a fractured comet, its strange behavior caused by volatile gases escaping from deep pockets beneath its crust. Others argued that its composition didn't support, that it didn't show enough water vapor or carbon dioxide, the signatures that typically define comets. Instead, there were faint traces of metals and complex organic compounds, suggesting it might be a rocky or even metallic fragment. That discovery alone was enough to ignite new debates, because metallic comets are exceedingly rare, especially those traveling at interstellar speeds. The presence of metal hinted at a violent past, a collision or planetary explosion in a distant system, sending fragments hurtling into the darkness. But there was something else that unsettled observers. The way 3I Atlas reflected sunlight didn't seem consistent with the rough, rocky surface. Instead, it produced glints, rapid bursts of reflection, that suggested parts of it were unusually smooth. A few of these reflections seemed polarized, meaning they scattered light in a specific direction, much like glass or polished metal might. This didn't sit comfortably with the idea of a natural object wandering for millions of years through the harsh environment of interstellar space. Cosmic radiation and micrometeorite impacts should have left its surface scarred, eroded, and matte, not mirror-like. To some researchers, that was the first whisper of suspicion. Was this object somehow preserved, or made of something far more resilient than expected? Public imagination began to fill in what science could not. Online forums and science communities started comparing 3I Atlas to Oumuamua, that first interstellar enigma whose strange acceleration and shape had sparked theories of artificial origin. The similarities were eerie. Both objects exhibited unexplained propulsion-like behavior, both reflected light in ways that defied conventional materials, and both seemed geometrically unusual. It didn't help that 3I Atlas arrived only a few years after Oumuamua, suggesting that maybe such objects weren't as rare as once thought. Could there be a population of interstellar visitors, some natural, some not, passing through unnoticed, with only a few lucky detections betraying their presence? Scientists, of course, tread carefully around such questions. Theories of extraterrestrial technology are thrilling, but they can also distract from the evidence. Still, History has shown that extraordinary discoveries often begin as uncomfortable ideas. A few researchers decided to explore the unspoken hypothesis that perhaps 3I Atlas could be more than just a rock. They approached it not with belief, but with method. Could an engineered structure mimic the signatures we were seeing? Could a thin, wide, reflective surface behave exactly as 3I Atlas did, propelled slightly by sunlight? The math said yes, it could. A light sail, for example, would experience precisely the kind of acceleration detected in both 3I Atlas and Oumuamua. The surface would be smooth enough to reflect light sharply, the rotation could be unstable due to asymmetric pressure, and the brightness variations would align with the data. But there was no proof. Only resemblance, and resemblance alone wasn't enough. Meanwhile, other scientists searched for explanations that stayed within natural bounds. They suggested that 3I Atlas might be composed of exotic ice, something like hydrogen or nitrogen that sublimates in ways difficult to detect. A hydrogen iceberg, for instance, could produce outgassing invisible to most instruments, giving the illusion of propulsion. But even that idea struggled under scrutiny. Hydrogen ice would be so fragile that it couldn't have survived a million-year journey through interstellar space, let alone billions. The interstellar medium would have stripped it apart long before it reached our sun. And so, the theories circled endlessly, each new possibility revealing another contradiction. The tension between science and suspicion grew with every failed explanation. The nature of discovery often sits in that uneasy middle ground between what the data tells us and what the imagination dares to suggest. In the case of 3I Atlas, the boundary blurred so easily because the evidence itself seemed designed to provoke wonder. The object wasn't giving up its secrets, and the instruments we had were straining to keep up. The more telescopes focused on it, the more it seemed to resist categorization, as if it were mocking our attempts to fit it into human understanding. Some astronomers turned to philosophical reflection. What if the universe routinely produces objects that look artificial but aren't? After all, nature has often fooled us before. Lightning mistaken for divine fire, pulsars once thought to be alien beacons. Perhaps the same was happening here on a grander cosmic scale, yet others countered that brushing off the possibility too quickly was a mistake. If even a fraction of interstellar objects were not natural, if even one turned out to be a relic of another civilization, it would change everything we know about life in the cosmos. It would mean that the great silence of space isn't absolute, that once, somewhere, intelligence rose, created, and left its mark drifting between the stars. Still, the data offered no definitive answer. What scientists did have were patterns, mathematical consistencies that could describe the motion, the spin, and the strange acceleration. But numbers alone cannot reveal origin. They can tell you how something moves, but not why it exists. As 3I Atlas moved farther from the sun, slipping away from the reach of our best instruments, it began to fade, leaving behind only streams of incomplete data and unanswered questions. The clues it gave us were precise yet ambiguous, and that ambiguity became a kind of mirror, reflecting our own curiosity back at us. For researchers, this tension between explanation and speculation became a test of discipline. Science demands patience, evidence, and repeatability. The unknown demands imagination. 3I Atlas sat precisely at the intersection of those two forces, a real object whose reality exceeded our models. To some, it was a puzzle waiting to be solved. To others, it was a reminder that the universe is under no obligation to be simple or comprehensible. Its shape, its motion, its strange resilience, all of it invited us to reconsider what natural truly means when viewed at a cosmic scale. Perhaps it was only our expectations that made it seem unnatural, or perhaps, hidden within that faint streak of light, was something truly extraordinary, something built long before our world even had a name. As 3I Atlas drifted farther from Earth, the challenge of studying it grew heavier, and the shadows of uncertainty began to stretch across every discussion. The further it moved into the darkness of space, the dimmer its light became, and with that fading brightness came the erosion of clarity. Telescopes that once captured sharp, measurable details now strained to detect even the faintest glimmer. The data that scientists depended on became thinner, noisier, more fragile. And in that fragile space, between what could be confirmed and what could only be guessed, doubt began to take root. The data surrounding 3I Atlas was already riddled with peculiarities: tiny fluctuations in brightness, irregular rotation, strange compositional readings that seemed to shift from one observation to another. Each research team interpreted these anomalies differently. Some said it was merely noise, an artifact of instrumentation limits or atmospheric distortion. Others argued the variations were too consistent to be coincidence. The smallest deviations in the numbers became grounds for debate, and in a discipline that thrives on precision, uncertainty is almost like heresy. Scientists found themselves not only studying 3I Atlas, but also defending their interpretations of it, as if the truth depended on the strength of conviction rather than the clarity of evidence. Data, for all its authority, is not immune to bias. It can be shaped by the instruments that collect it, the methods that process it, and even the expectations of the people interpreting it. In the case of 3I Atlas, those expectations were already extraordinary. The public had seen the story before with Oumuamua, and that collective memory colored the entire investigation. Every unexplained flicker, every unexplained acceleration, was immediately compared to that earlier mystery. It became nearly impossible to examine 3I Atlas as an independent phenomenon. It lived in the shadow of its predecessor, and within that shadow, doubt wasn't just scientific, it was emotional. The fear of being wrong, of overreaching, or of missing something historic, all lingered behind every calculation. Some researchers took a cautious stance, retreating into mathematical conservatism. If the data didn't fit known models, they reasoned, perhaps the models needed only slight adjustments. Maybe a hidden factor like the angle of sunlight or the internal structure of the object could explain the strange readings. But others felt that such caution was a disguise for discomfort. They believed that sometimes data challenges us precisely because it's pointing toward something new, something beyond the boundaries of established physics. In that sense, doubt became not a weakness, but a creative force, a signal that we were standing on the edge of discovery. Yet there was a darker side to this uncertainty. As 3I Atlas continued its journey out of the solar system, the flow of new information slowed to a trickle. Observatories could only capture brief, faint readings before the object dipped below detectability. Each new dataset carried a heavier burden of error, forcing scientists to rely more on extrapolation than observation. Extrapolation, though useful, is a fragile bridge. It assumes that what we've seen continues to behave in predictable ways, even when we can no longer see it. But what if 3I Atlas wasn't predictable? What if its behavior changed once again, unseen, beyond our reach? Some began to notice patterns that almost seemed deliberate, small but repeating fluctuations in brightness that looked rhythmic rather than random. Others dismissed these as coincidence, arguing that with enough data, even randomness can produce patterns that appear meaningful. But those debates began to fracture the scientific community into camps of believers and skeptics. The believers were not necessarily thinking in terms of aliens or technology, but in terms of significance, that this object, whatever it was, represented a new category of interstellar visitor. The skeptics clung to caution, insisting that anomalies are not miracles. They are misunderstandings waiting to be clarified. This tug-of-war was not new to science. It echoed through history: Galileo's defiance of the geocentric model, the early debates over quantum mechanics, the skepticism toward dark matter. In each case, the unknown began as a disturbance, a shadow on the data that didn't belong. 3I Atlas became one of those disturbances, and like all such moments, it forced scientists to confront not only the limits of their tools, but the limits of their imagination. How do you interpret data when the data itself seems to shift beneath your feet? How do you maintain objectivity when the universe whispers something that sounds almost intentional? The doubt grew heavier as attempts to model its behavior produced inconsistent results. Simulations failed to align with observation. Even when the orbital path was recalculated using new data, the numbers didn't fully agree with earlier projections. A few astronomers noticed something unsettling: tiny discrepancies between expected and observed positions, as though 3I Atlas had experienced slight bursts of acceleration at unpredictable intervals. Those could have been due to outgassing, yes, but no trace of gas was ever found. If it wasn't a jet of vapor, what was it? Radiation pressure? Magnetic influence? Something else entirely? Each explanation seemed to open more questions than it answered. As the mystery deepened, the media amplified the confusion. News outlets seized on every scientific update, often exaggerating the weirdness or framing it in sensational tones. Headlines spoke of alien probes and cosmic messengers, feeding the very speculation that scientists were trying to restrain. Public fascination became both a blessing and a burden. More funding, more attention, but also more pressure to deliver answers that might not exist yet. The line between exploration and entertainment blurred, and 3i Atlas became not just an astronomical event, but a cultural one. In the quiet of observatories, beneath domes turning slowly against the night sky, the scientists working on the data felt that tension most acutely. Every number mattered. Every uncertainty had to be accounted for, every anomaly revisited. Nights turned into weeks, then months, and still, no consensus emerged. The data, like the object itself, remained elusive. For some, that was the point. The beauty of astronomy lies in its incompleteness. The universe doesn't hand us answers. It offers hints, and we build meaning from the fragments. For others, the lack of resolution was maddening. To spend years chasing an object that slips away, leaving only noise in its wake, feels like trying to solve a riddle written in a language the cosmos has long forgotten. As 3 Atlas faded into the distance, beyond the reach of even our most powerful telescopes, the final datasets arrived scattered, low resolution, and filled with ambiguity. Some readings suggested the object was tumbling erratically, others hinted that it had stabilized. The reflected light fluctuated, but not enough to confirm a change. The last signals were faint enough that some scientists questioned whether they were even real or simply artifacts of background interference. It was as though 3i Atlas, realizing it was being watched, decided to vanish into the noise, taking its secrets with it. The scientific papers that followed were cautious, restrained, written in the careful language of probability and possibility. Each word weighed, each claim softened by uncertainty. The shadows of doubt became part of the story itself, a reminder that not all mysteries yield to observation. For every answer we reach, there are hundreds of questions that slip just beyond our grasp. 3i Atlas became one of those questions, a symbol of how data can illuminate and obscure at the same time. It forced us to confront the uncomfortable truth that sometimes the most precise instruments in the world can only capture the faint outline of a mystery that refuses to be defined, leaving us suspended in that fragile balance between belief and doubt, between knowing and wondering. By the time 3 Atlas had receded into the outer darkness of the solar system, what remained of it on Earth was not the light of its passing, but the record of its movement, a trail of data, a faint echo preserved in motion. In astronomy, light is memory. Every flicker, every spectral line, every subtle deviation from prediction becomes part of the universe's written history. 3i Atlas left behind such a history, inscribed in graphs, numbers, and measurements scattered across observatories around the world. To the untrained eye, these records looked like static, but to those who knew how to listen, they carried a story about time, energy, and distance, a cosmic echo of something ancient that had drifted across the interstellar void long before humanity ever existed to name it. The concept of motion in space is deeply poetic, but it's also profoundly mathematical. Objects like 3i Atlas move not by choice, but by consequence, the consequence of gravitational pulls, collisions, and ancient forces set in motion billions of years ago. Its journey wasn't a path designed for discovery. It was the result of a cosmic accident, perhaps the violent birth of a star system, or the death of one. Somewhere, far beyond our telescopic reach, a chain of events long forgotten sent fragments flying into the void. And one of those fragments, against impossible odds, found its way here, passing briefly through our neighborhood before vanishing back into infinity. That moment, brief as it was, allowed humanity to observe something older than any of our histories. When scientists reconstructed the trajectory of 3i Atlas, They realized that the object had not just wandered aimlessly, it carried a precise direction, a motion that aligned with no known planetary or galactic path. It came from nowhere familiar and was going toward nowhere charted. Unlike comets native to our solar system, whose orbits are bound by the sun's gravity, interstellar visitors move with a freedom that feels almost alien. They pass through, untouched by our gravitational prison, bending only slightly before escaping again. That trajectory itself became a kind of message, a signature of other star systems whispering their existence through debris. The velocity, the angle, the arc, all were clues pointing toward the vast machinery of the galaxy at work. Invisible yet precise. In studying those clues, astronomers began to notice resonances, mathematical harmonies between 3I Atlas's motion and that of other interstellar visitors, like Oumuamua and Borisov. These resonances weren't coincidences. They were cosmic fingerprints. They suggested that such objects might originate from similar galactic regions or be ejected by similar mechanisms: stellar births, gravitational slingshots, or catastrophic planetary disruptions. In that way, 3I Atlas wasn't just an isolated traveler, it was part of a larger pattern, a symphony of celestial fragments moving through the Milky Way like ancient messengers. Every interstellar object we detect is a fragment of another world, each carrying echoes of chemistry, history, and motion from systems we may never see. These echoes are faint, but profound. When astronomers analyzed the minute variations in its velocity, they found traces of non-gravitational acceleration, tiny pushes that couldn't be fully explained by sunlight alone. To some, this hinted at sublimation, frozen gases releasing jets that slightly nudged its path. To others, it hinted at something else entirely, something structured, something engineered, perhaps even something responding to forces in ways we did not yet understand. Whatever the cause, those slight deviations were not just errors. They were the universe's quiet language, subtle inflections in the rhythm of motion that told us there was more to the story than geometry. The concept of cosmic memory became a recurring metaphor among the researchers. They spoke of how objects like 3I Atlas are not merely travelers, but archivists of the cosmos. Their surfaces hold chemical records of ancient star systems. Their trajectories record gravitational histories of the places they've passed through. Even their shapes, elongated, jagged, or polished smooth, are shaped by the physics of alien skies. Each detail is a clue, a syllable in the long and silent conversation the universe has been having with itself since the beginning of time. And so, in studying 3I Atlas, humanity was, in a sense, reading a page torn from a book written in starlight. The motion of 3I Atlas also forced scientists to confront the vastness of scale in a new way. At interstellar speeds, time itself behaves differently, not in a relativistic sense, but in a perceptual one. To us, its passage through the solar system seemed fast, a fleeting event measured in months. But to the object, to the cosmic timeline, that passage was just an instant, a fraction of an endless voyage spanning millions of years. The object had likely crossed light years of emptiness, untouched by any star's warmth, before it came close enough for Earth to notice. Imagine traveling through that kind of silence: no sunlight, no heat, no sound, just the cold geometry of motion sustained by inertia and history. 3I Atlas had been doing that for eons, carrying with it the physics of its origin, like a ghost carrying a memory it could never share. For the scientists mapping its trajectory, that realization carried a strange sense of humility. Human life is brief. Civilizations rise and fall in the time it takes such an object to move from one star to another. To measure something that has existed for millions of years, and will continue for millions more, is to stand in the presence of cosmic endurance. It forces a re-evaluation of what permanence means. The object didn't care about being seen, didn't need an observer. Its motion, its existence, its journey, all of it would continue long after our species is gone, long after our instruments have turned to dust. We merely caught it mid-flight, a single frame in an infinite film reel. Even as it faded, telescopes continued to track its trajectory by prediction. Astronomers could no longer see it directly, but they could calculate where it should be a ghost trail through the dark. In doing so, they turned 3i Atlas into something both abstract and eternal, an equation that would outlive the data itself. Its memory, encoded in numbers, now exists in archives and simulations, preserved for future generations to study, to question, to rediscover. That digital echo light transformed into data into theory, is how modern science keeps the cosmos alive long after its light fades. What 3i Atlas ultimately gave us was more than mystery. It gave us motion as memory. Every observation, every recalculation, every doubt became part of a larger narrative about how the universe moves and remembers itself. The objects passing reminded us that even the smallest fragment of cosmic debris can carry the essence of entire worlds. That the void between stars is not empty, but full of stories, waiting for the right instruments and the right imagination to hear them. 3i Atlas was one such story, a drifting echo of creation, crossing our sky for a brief, silent moment before continuing its endless journey across the galactic night as the echoes of 3i Atlas faded from our telescopes. What lingered was not just a trail of disappearing light, but a profound sense of unease wrapped in wonder. Humanity had once again witnessed something extraordinary, an object that seemed to belong and not belong to our understanding of the universe. It had come uninvited, drifted across our solar system, defied our classifications, and then slipped back into the darkness from which it came. And in that brief passage, it left behind one final question. What if the universe isn't simply stranger than we imagine, but stranger than we can imagine? To gaze into that question is to peer beyond the veil of understanding, into a realm where our equations still work, but our meaning does not. The story of 3i Atlas was never just about an interstellar visitor, it was about the limits of perception and the boundaries of human comprehension. Even with our most advanced technology, our vast archives of cosmic data, and our centuries of accumulated astronomical knowledge, this object managed to slip through, refusing to yield a definitive identity. It was like a word in a language we almost recognized, but couldn't translate. The more we studied it, the more it seemed to pull away from our frameworks, hinting at the existence of realities that lie just beyond our intellectual horizon. For scientists, this kind of mystery is both thrilling and disquieting. Every new observation expands the perimeter of what we know, but it also expands the perimeter of what we don't know. 3i Atlas became a symbol of that paradox, a reminder that progress in science isn't measured only by answers, but by the quality of the questions that remain. Its presence forced astronomers to revisit their assumptions about how interstellar objects form, move, and survive. It reminded physicists that even in a universe governed by elegant laws, anomalies are not exceptions, they are invitations. Invitations to rethink, to rebuild, to peer deeper into the structure of existence itself. As data analysts combed through the last remaining signals from 3i Atlas, they found inconsistencies that refused to disappear no matter how many corrections they applied. The object's rotational period didn't behave as expected, suggesting either an irregular shape or a material composition that reacted unpredictably to sunlight and thermal pressure. Some spectral readings suggested silicate rock. Others hinted at metallic or carbon-based compounds, even traces of organic molecules that didn't belong to the standard catalog of cometary materials. And so, theories multiplied. Some proposed that the object was a fragment of a shattered planet from a distant system, flung into interstellar space by gravitational chaos. Others speculated it might be a remnant of something constructed, perhaps long dead, perhaps long forgotten, drifting like cosmic debris from a civilization far older than ours. But there was something deeper behind all these theories, a recognition that we were staring into a kind of mirror. The mystery of 3i Atlas didn't just reveal the unknowns of the cosmos. It revealed the contours of our own limitations. It showed how much we rely on pattern, on familiarity, on categories built to make sense of a universe that often refuses to cooperate. When we can't classify something, we start to feel the edges of our ignorance pressing in, reminding us that knowledge is not a conquest, but a negotiation. The cosmos allows us glimpses, but never the full view. It teaches in fragments, whispers in data, speaks through paradox. There's something humbling in realizing that after centuries of astronomical progress, after learning to map galaxies, decode starlight, and detect exoplanet orbiting faraway suns, we can still be surprised by a single object, barely a few hundred meters wide. It exposes how small our observational reach really is, how fragile our grasp of the cosmic whole remains. 3i Atlas reminded us that even in the age of AI-driven telescopes and deep space sensors, there are things we may never fully understand. It's not that our tools aren't powerful, it's that the universe is vast enough to stay one step ahead. The deeper we look, the more intricate it becomes. As if designed to ensure that curiosity never finds an endpoint, the strange persistence of mystery surrounding 3i Atlas brought an almost philosophical tone to the scientific community. Some compared it to the deep-sea creatures discovered in the twilight zones of Earth's oceans, forms of life that seemed to rewrite biology just by existing. Others compared it to the early moments of quantum physics, when particles behaved in ways no theory could predict, forcing a complete transformation of human understanding. 3i Atlas felt like that kind of threshold, a moment when the cosmos whispered that it was time for our ideas to evolve again. Not because the universe had changed, but because we had reached the edge of what our minds could comfortably explain. For astronomers, the veil became a metaphor repeated in papers, conferences, and quiet discussions after long nights of observation. The veil was not a literal barrier, but a conceptual one, the thin membrane separating what we can observe from what we can interpret. On one side is the measurable, the tangible, the defined. On the other is the ineffable, the realm of phenomena that seem to mock our categories. 3i Atlas hovered precisely on that boundary. It was both measurable and mysterious, real and elusive. A physical object that seemed to carry within it something metaphysical. As the last glimmers of 3i Atlas faded into the endless night, humanity was left not with answers, but with a new kind of silence, a silence filled with wonder, humility, and the quiet pulse of curiosity. The story of this strange interstellar visitor was never just about an object from the stars. It was about us, our relentless desire to understand, to categorize, to connect the unseeable to the familiar. 3i Atlas arrived like a cosmic question mark, drifting through our solar system for only a brief moment, yet leaving behind echoes that may linger for generations. It reminded us that the universe is not a solved equation, but a living, breathing expanse of possibility. Science often moves forward not through certainty, but through mystery. Every anomaly, every flicker of light that refuses explanation, becomes the beginning of a new pursuit. 3i Atlas reminded astronomers that even in an age of supercomputers, AI, and space telescopes, the cosmos still has the power to surprise us, to disrupt our models, to challenge our confidence, and to reignite that childlike awe that first made us look up at the sky. In its brief passage, it shattered our assumptions about what interstellar objects can be, forcing us to confront the truth that knowledge is always incomplete and that wonder is not a weakness, but a form of strength. For many, 3i Atlas became a symbol of how science and imagination intertwine. Its uncertain nature, part comet, part mystery, perhaps something entirely new, blurred the line between the known and the unknown. Some saw it as a relic of ancient cosmic violence, others as the possible artifact of intelligence lost to time. But whatever it was, it served a greater purpose. It made us look deeper, think differently, and admit that we still stand at the beginning of understanding the galaxy we call home. There is a poetic symmetry in the fact that 3i Atlas, an object that began its journey countless years ago from an unseen corner of the universe, would cross paths with the species just beginning to comprehend its place in the cosmos. For a few short weeks, our worlds intersected, the ancient and the newly aware, before parting again, each continuing its journey through the great expanse. And in that meeting, something profound happened. We were reminded of scale, of time, of fragility, of how small we are, and yet how vast our curiosity can be. Somewhere, far beyond the light of our sun, 3i Atlas continues its eternal flight, silent, cold, and unobserved. But here on Earth, its journey continues in another form, in the minds of those who watched, who questioned, who felt the thrill of standing at the edge of the unknown. It may have come and gone without revealing its true nature, but in doing so, it fulfilled a deeper purpose. It reminded us why we look up in the first place. Because in every mystery, there's a reflection of ourselves, and in every unanswered question, there's a spark that keeps the human spirit awake beneath the infinite night sky.